Hello, I'm Dr. Ed Geringer, and I'd like to welcome you to CSC-ECE 506, Architecture of Parallel Computers. The website for the course is http://go.ncsu.edu/CSC506 or ECE 506. It links to the Moodle pages as well as to other resources for the course. This course has 5 learning objectives. The first one is to understand the problem of race conditions in concurrent systems. If you have a serial program, it carries out operations in exactly the order that the program specifies. But if you have multiple threads or multiple processes working at the same time, you don't know whether one of them is going to get ahead of the other one. And they need to synchronize their accesses to make sure that when one of them writes a variable and the other one reads it, the one that writes it actually does the writing before the other one does the reading. And if there's any doubt, that's a race condition. The second one is to learn how to decompose a program for parallel execution. When you have a large computation, you need to divide it to work on multiple processors and figure out a way to send data back and forth between different parts of the computation. Some of the variables in a multiprocessor program will need to be shared between the different processors or threads because they're used for communication. But other variables, like loop control variables, will be private to an individual processor. Looking at a program and learning to identify which are private and which are shared is goal number 2 of the course. Third is to be able to write simple parallel programs in the important parallel models. And there are 3 important models. The first is shared memory. In shared memory, threads share memory. One can write to a location, and another thread can read from the same location. Then there's message passing, in which any data that needs to go from one process to another needs to be sent by the first process and then received by having the second one execute a receive operation. And lastly, there's data parallel, where there's a single instruction stream which is applied to many data items at the same time. A GPU is an example of that. The fourth objective is to understand the operation of common cache coherence protocols, both bus-based and network-based. You know that for fast reference, any architecture will put recently referenced data into a cache, which is a small, fast memory. And then the processor, the next time it needs it, can get data from the cache. It doesn't need to go to main memory. But if you have multiple processors sharing data, that data needs to be kept coherent. In other words, if one processor changes that data element, that change needs to be reflected at all of the other processors that have it cached. Arranging that is the job of the cache coherence protocol. Now in a small system, you can use a bus-based protocol because all of the processors share a single bus. But a larger system uses a network, and transactions may be able to pass each other in the network. And then you need to use very different protocols to make sure that variables get updated as they should. But that's not the only problem referencing memory. In a processor that uses an interconnection network, it takes time for references to be seen in the far reaches of the network. And that can cause references to be seen out of order with respect to the time that they were issued. Dealing with that because the fastest consistency models require programmers to be aware of and to adapt to how they work. Now our textbook for the course is Fundamentals of Parallel Multicore Architecture by Jan Solihin. Jan was a professor of ECE at NC State for many years, and he left to start a new program at the University of Central Florida about 3 years ago. But before he did that, he wrote a textbook on what we'd been teaching in the 506 for the last several years. And there's the book. There's an old edition from 2009 and a new edition from 2016. I encourage you to get the 2016 edition because the 2009 edition is missing material for maybe 20% of the classes this semester. This edition is available through the NCSU Library's All-In program for digital delivery of course materials through links on your Moodle page for about $36. Not counting exams, there are 26 sessions in the course, usually on Monday, Wednesday, and Friday. Each of the 26 sessions consists of a reading, a quiz over the reading, and a set of videos. Actually, for the first class, the quiz is on the syllabus instead of over a reading, but all other quizzes are on the readings for the class. You can skip one quiz and one set of videos, not necessarily the same one, without penalty, so really you're required to pass 25 out of 26. I have it set up so you can tell me whether you want to do the readings before watching the videos, or watch the videos before doing the readings. Currently, it's set up so everybody does the reading first, followed by the video, but I'll send you a form that you can fill out to opt into doing the videos first. If you do the reading first, your quiz deadline will be on the day of the class, and your video deadline will be 2 days later. But if you do video first, your video deadline will be on the day of the class, and your quiz deadline will be 2 days later. If you miss more than one video or more than one quiz, you lose points off of your semester average. Let's say you skip 5 quizzes. After the one you can skip for free, you're penalized for the other 4, and you lose 0.5 points times 4, or 2 points from your semester average. You pass a quiz by scoring at least 80% on it, on the questions that can be auto-graded. Any free text responses on the quiz don't count. To pass the videos, you just need to answer all of the embedded questions. We won't grade the answers this semester, though in later semesters we might. Note that both the syllabus quiz and the Lecture 2 quiz or Lecture 2 videos are due on Friday, just before midnight Eastern Time. For later classes, one will be due on the evening of the class day, and the other 2 days later. Videos in this class will be delivered through PlayPosit, which is a system for interactive quizzing and note-taking. Here's a short video on how to take notes. Yep. Well, unfortunately, it doesn't seem to want to play for me right now, but I'll give you a link to it so you can play it for yourself. When you take notes in PlayPosit, you'll be able to see them through the rest of the class. So will the instructor, and I can use them to see how well students are understanding the material. They will not factor into your grade. Almost all of the videos include a quiz, and you need to submit answers, right or wrong, to all quiz questions to get credit for the videos for the day. Okay, so here's the homework for the semester, which is worth 51% of your grade. There are 4 programs, 3 problem sets, and 3 peer-reviewed made-up problems. The programs and problem sets are each worth 6%, and the peer-reviewed problems are worth 3% each. Tests are worth the remaining 49% of your grade. There will be 2 midterms and a final. The first 2 programs are going to be parallel programs. The last 2 are going to be simulations of cache coherence. The 3 problem sets will be spaced out over the course of the semester on material that we cover in class. These won't be questions from the textbook. They'll be new questions for which you can't find the answers online. And now I want to talk a little bit about the peer-assessed exercises, the made-up problems. One made-up problem will be due along with each problem set. These will be submitted to our Expertise peer review system, which we'll talk about a little bit later. You can make up a problem that's like the ones we gave you for homework and submit it, and then some of your fellow students will review it and give you suggestions, and then you can go revise your program and submit it. If I have time, I'll also take a look at your problem and give you suggestions. And after you revise your problem, I'll give you a grade. The tests add up to 49% of your grades. The first one is worth 10% of your grade, second 15%, and the final exam 24%. The reason for doing it that way is that it sometimes takes people time to get acclimated to the way we run exams. In that way, if you don't do well on the first exam, it doesn't count against you very much. The exams will be open book and open notes, but you must not communicate with anyone else during the exam. I will email the exams to you. You will print them out and then scan them back in to submit them. We will arrange a time so everybody can take the exam and submit it a few minutes after time expires. Let me know if printing is going to be a problem for you. Okay, so now I've talked about the homework. I haven't yet talked about extra credit. The general rule in my class is that in order to get extra credit, the activity you perform must help other students learn the course material. I have some examples here. First is for making outstanding contributions to answering other students' questions on Piazza. You can get credit for being in the top students in the class in terms of number of answers or number of questions that the staff or other students think were good questions, or the number of your answers that they think were good answers. Second is contributing useful practice problems via Peerwise. Peerwise is a system that was set up for students to devise sample test questions and give them to other students to work on. We'll set it up about a week before each of the exams so you can use it to study for them. Now it's totally voluntary. If you don't want the extra credit or don't need to study for the exam, you don't need to do it. But if you do it, you can earn extra credit for your contributions. The system keeps track of how many people work on your problems and how many people get them right, and whether your answer is deemed by the class to be the correct answer. So you can get credit for contributing useful practice problems. Third, you can get credit for doing extra peer reviews of made-up problems by your fellow students. For each peer-reviewed problem you submit, you're required to review 2 others and can review up to 2 more for extra credit. Finally, you can suggest web or print resources that will help other students make up useful made-up problems. If you don't want to make up a problem by yourself, but you saw a really good one that somebody else might want to emulate, not copy, but emulate, then you can get extra credit for telling them. So there are lots of ways to get extra credit in this course. Okay, I said I wanted to tell you a little bit about the course, and now I want to talk a little bit about myself. This is my family, a family picture that was taken last year at my wife's birthday. And I often say that my family is the second most important. The fellowship sponsors ads in the Technician several times a year. This is our most recent ad from Easter last month. You can read a little bit about the Christian significance of the holiday. Now normally, if this were a fall or spring semester, I would invite you to Bridges Lunch for international students, which is run by another Christian ministry on campus. It's typically on Friday at 12:30, so I hope you remember, and I hope that I'll see you there next fall. At this point, I would normally tell you who the TA is, but since I haven't hired one, I'll email you as soon as I know.